our second chapter talks about simple electrical circuits, but it starts out talking about fractions. And the first thing it talks about is simplifying a fraction. We find the greatest number that divides evenly into both the numerator and the denominator of a fraction, the top and the bottom, in other words, and we divide both of them by that number. When the number and denominator have no common divisor except 1, the fraction is its lowest terms. Okay. We multiply the denominator of the fraction by the whole number. If we want to change a mixed number to an improper fraction, then we multiply the upper number by the whole number and hold that bottom one, and then add the numerator of the fraction. So, no, numerator. We're going from a mixed number to improper fractions. In other words, a whole number and a fraction to just a fraction. Let's say we have 2 and 5/8. We would multiply the 2 times the 5, right? No, times the bottom. Times 8. So 2 times 8 is 16. So we'd have 16 eighths plus the 5/8 we had before. That'd be 21 eighths. See it? Okay, I did say it wrong the first time, didn't I? All right. Nothing unusual about that. Now, more importantly, change the improper fraction to mixed numbers. Go back the other way. I'm sure you guys did practice in this in your homework, or you're going to.
Yes, sir.
Certainly did a lot of this, right? Okay. Why do you think that is?
You'll figure out how to make a conduit.
That's exactly correct. You must be in the other class too. Okay. Multiplication of fractions. We're going to have to multiply fractions sometime, right? Okay. And it's easiest if you get a common denominator, right? You can multiply the denominators, but often you can see a common denominator and multiply both top and bottom of that fraction by that number to get them common. Okay? An example of, now before I go on, I want to point out that a lot of the things you do in electrical work, you do from a tape measure. Then you turn that into a decimal point, you do some multiplication or some addition and some multiplication, move it around, do some stuff with it, and then you go, oh, I need to put that on my conduit or something. I need to use my tape measure now. Now you've got to convert back. Okay, that's a skill you're going to need, and I call that ballparking to get to the nearest 16th, and we'll talk about that in just a minute. Okay. 1/2 turn will close the jaws 1/2 of 3/8 inch. In this sense, the word of means multiply. So 1/2 of 3/8 is 3/16. Okay. Multiplication of mixed numbers. Change the mixed numbers to improper fractions. Multiply the fractions. Divide the numerators and denominators by the common factors. Okay. Now, what we're going to do now is we're going to have the Ohm's laws. And I'm going to tell you my method of remembering them, and you're going to do it the same way. Okay, voltage. E is equal to I times R. E must always be expressed in volts. I must be expressed in amps, and R must be expressed in ohms. So let's solve a simple EIR problem. And anytime we're solving any problem, read the problem carefully, draw a simple diagram. This does not just apply to this right here. This will apply to a lot of electrical problems. Very often you want to make a drawing of what you see in your head and start writing down what you know and what you want to know. And usually, if you've got Ohm's law in mind, suddenly you'll have two things you have, and that'll tell you the thing you're looking for, and then you'll be able to solve everything. So this is not just for these formulas, but they're for doing everything in the future. Okay. Okay. Applying Ohm's law. Okay, we've got these nice simple problems. And I'm going to stop here, and we're going to create what I call a 3x5 card. Let me actually hit pause, and I'm going to hand out cards. Okay, we're going to make a 3x5 card. In the upper left-hand corner, we're going to put a circle. We're going to draw a line a little above the halfway point, and then we're going to draw a perpendicular line from the middle of that down. I'm going to write P, E, I, pi. And on the other side, we're going to draw the same lines, except we're going to write E, I, R. Now, those are all the Ohm's law you're going to need to know. And you can remember it by saying that it's the pioneer wheels, pi and ear wheels. So now you know that it's got a name, pioneer wheels. Why is that thing flashing? So, what we want to write in the middle of this is series rules. And the most important one is that current is constant. Rule number 2, voltage is additive. And 3, resistance is additive. And power is always additive. Now, what do we mean by that last one? We only mean true power, not apparent power. True power is always additive. Apparent power is not always additive, especially if we're talking about an AC circuit with inductance, but that's a whole different opener. Now, you notice I used the whole card, but you should have left some space down at the bottom, especially down here in this left-hand corner down here, I hope. I hope you wrote smaller than I did, and you left some space down there because we're going to put another rule down at the left-hand corner if you have some room, but we'll do that later. On the back, we're going to write the parallel rules, but we're not going to do that just yet. But I want you to realize that you can get 2 more rules out of this because you may not be able to figure out everything in the whole world that you run into with just those 8 rules. Because each one of these is about 8 rules, right? P is equal to E times I. E is equal to P over I. I is equal to P over E. If you put your finger over any place, you get a rule, right? So there's at least 3 rules on the left, 3 rules on the right. That's about 6 rules. And that may not get everything you need to do. You may be tempted to get one of those little round stickers that has 5,000 formulas on it. Forget about that. You don't need it. We're going to take the E that's on the right side of this thing. We're going to plug it into the E that's over here. So we're going to get a new formula. E over here is I times R, right? Everybody agree to that? So we're going to get a new formula where P is I times R, and E is I times R, and I is still I. So we get a new formula. P is equal to I times I, or I squared, R. P is equal to I squared R. That's a new formula that we just derived from our pioneer wheels. We took the E from this side, and we see this I times R. We plug that in over here where the E is. We got a new power formula. That is the power formula. Actually, that's called the heat formula. Then we're going to get one more. It's not quite as useful. We're going to take the I from this side. And we're going to take that I and we're going to replace it with this I over here. So now we have P over E times the I over here is E over R, right? E over R. So from this formula, we get P is equal to E times E, we call that E squared, over R. And that can be a handy, useful rule. And now that I've explained about the pioneer wheel, wheels, pioneer wheels, and how to derive the other two formulas, I fully expect you to remember these just for the next 18 or 20 years. Okay? So certainly if we have a quiz next week, I would thoroughly expect you to remember the pioneer wheels and the series rules. Okay? We're not going to jump into parallels yet, but at least we have the series rules. Current's constant, voltage is additive, resistance is additive, power is additive. So we know a couple of things now. All right, our next slide in our book here talks about changing fractions to decimals, which is something we do. We're going to take our tape measure measurement, and we're going to create a decimal function from that. How do we, if we have 7/8, how can we find out what 7/8 is in decimal? We can divide 8 by 7 possibly. 7 into 8, whatever. I don't think of it that way, and I'll tell you why. Because when we come back out of this and we need to go back into fractions, we have to ballpark to the nearest eighth and then figure out where the nearest 16th is. So this is very nice. Getting into a fraction is nice, but I want you to remember from now on that an eighth is, as it shows right here, so I no longer have my writing implements. No, not from beginning for the current slide. Oh, darn it. Nope. Gotta hit pause. I messed up. Sorry. All right, so we're going to talk about eighths and sixteenths real quick. Now, of course, we need to work with powers of 10, but we don't work in powers of 10 in electrical work. We work in powers of 1,000. I think we're down to the end of this slideshow anyway. I think quiz B, yep, that's the end of it. Okay, good. Let's go back to my, did I turn the recorder back on? I did not. Good. No, I did. Darn it. On. Are we rolling? We're rolling. Okay. 1/8, as the thing just pointed out in our last slideshow, pointed out that 1/8 is equal to 0.125. And I want you to think of that as $1.25, because that way it's really easier to multiply up. Because you know a lot of the eighths already. Like 2/8 is known as 1/4, because we can divide both top and bottom by 2 and wind up with 1/2, and that's equal to 0.5, right? Okay, so 8, 1/8, 2/8, 3/8. If I give you $1.25 3 times, how much money do you have? You have $3.75, right? I'm telling you, it's easier to remember if you think of it as money. Okay, $0.50 is 50 cents still, right? And that's 4/8. Okay, 5/8 is another odd one that's all by itself. If I give you $1.25 5 times, how much money do you have? 6 1/4. $1.25. Yeah, we're gonna do some deals, okay? Okay, 6/8. If you reduce this, multiply both top and bottom by 2, you'll wind up with 3/4, right? And everybody knows that 3/4 is 0.75. You've gotten that since 2nd grade or 3rd grade, right? And what's the next eighth past 6/8? 7/8. Now this one's hard. This one's tricky. If I give you $1.25 7 times, how much money do you have? $8.75. $8.75 or 0.875. Now, if you have this list in your mind, and you do from now on, then you can find the nearest eighth just by looking at the number. Let's say you're trying to convert back from, you've done some calculations, you now need to find out what that means to where you're going to put a mark on your tape measure, right? Now let's look at 5/8 for a minute. 0.625. Now I want to multiply this times 2, all right? Actually, I want to multiply it times 2 over 2, which is just 1. So it's the same thing, right? As long as I multiply by 1, it's still the same thing, right? So 10/8 10/16. Sorry. Oh, that's not back in. Actually, let me try this. Yeah, like that. Now, the reason I put this up here is because we need to know 1/16. And the trick to remember that is 5/8 is 0.625. And that's equal to 10/16. Would you agree to that? What is that doing? 10/16. Well, we want one of those, not 10 of them, right? So 1/10 of 0.625, we're just going to move the decimal place 1 point, right? We're going to move the decimal point 1 place over because we're going to divide this by 10. We'll find that's 0.0625. So now you can always remember that 1/16 is 0.0625. So now if we're trying to find a number and convert it back to tape measure, we would ballpark to the nearest 8 first and then add or subtract a 16th to find the nearest 16th. And at some point we'll have a quiz where you will be given a number and you'll convert back to the nearest 16th. And it won't come out evenly. It won't come out on an exact 16th. You've got to choose the nearest 16th, all right? That okay? All right, that's it for today. I want to thank you for your patience with my technology here.